To form a base for our projects, we'll need medium density fiberboard. This will be used to create the mounting surface for our speakers and also to act as braces to temporarily hold the mounting baffles in place. A jigsaw will be necessary for cutting the irregular shaped speaker baffles and for trimming the braces to the proper size. It can also be used for cutting the speaker rings if a router is unavailable. A power drill will be used for any screw holes. A plunge router will be used in combination with a circle jig for creating the speaker rings as well as for rabbiting the edge of the spare tire well baffle. The circle jig being used is the M200 from Jasper Audio. These are available directly from Jasper Audio as well as Parts Express. A fixed base router will be used in a small homemade router table to do any flush trim and roundover work desired. The plans for the router table I'm using are available on the internet. If you would like the plans, I have provided a link in the included documentation. We'll be using 4 different router bits. The 1/4-inch straight cut bit will be used with the circle jig to create the rings and mounting holes for our drivers. The 3/8 inch roundover bit will be used in the router table to take the hard edge off the outer edge of our flush mounting rings. The rabbiting bit will be used to add a lip around the edge of our spare tire well enclosure baffle. The 1/2-inch flush trim bit will be used to cut away the excess material from our fiberglass baffle mounting rings. A die grinder will be used in conjunction with the 1/2-inch flush trim bit rather than a bulky router. An electric unit such as a Dremel or rotozip could be used with a spiral cutting bit if air tools are not available. A body saw is also recommended for cutting the fiberglass to the needed shape after curing. Again, a Dremel or rotozip with a spiral cutting bit could be used. An angle die grinder will be used for sanding the enclosures. An electric sander could be used instead of an air sander. A rotary sander is recommended over an orbital or jitterbug sander in this case. A staple gun should be used to attach the cloth to the edge of the wood enclosure to ensure a strong bond. An air-powered model is recommended, but an electric or hand stapler will work if 1/2-inch staples are used. A pair of scissors and a razor knife will be needed for cutting and trimming the various polyester cloths that will be used. These do not need to be of a high quality, but they do need to be relatively sharp. A heavy-duty pair of shears needs to be used for cutting the fiberglass cloth and mat. I prefer to use a cheap pair from a dollar store rather than maintain a quality pair of shears. When the cheap ones wear out, I simply purchase another pair. CA glue and hot glue are used to quickly mount the MDF braces to the base and mounting rings from the fiberglass enclosures. CA glue forms a better bond, but hot glue is thicker and can fill in gaps between the brace and the ring. To form the first layer of our wrap shape, we'll need a variety of polyester-based cloths. Polyester is a good choice because it is stretchable and is the same material as our resin. Thinner cloths will be used for more complex shapes, and thicker cloths will be used for enclosure baffles. To temporarily hold the polyester cloth in place, we'll use spray glue. I recommend Super 77 from 3M as a good all-purpose spray adhesive. Fiberglass mat will be used to form the base of our spare tire well enclosure and to duplicate the shape of our factory kick panels. Mats come in various thicknesses or weights and are sold by the yard. The most popular weights are 1.5 ounce and 3 ounce. The thinner the material, the more readily it will take resin and bend around curves. The thicker the material, the stronger it will be when cured. I recommend purchasing some of each. We'll also be using a material called core mat. This acts as a bulking agent and will save time and money on our spare tire well enclosure. It comes in 2 mil and 4 mil varieties. I recommend the 4 mil for enclosures. To saturate and cure our cloth, we'll need polyester resin and MEKP hardener. This is what will give our cloth strength when cured. Resin is sold by the gallon and usually comes with enough hardener to mix the resin at 1%. I recommend purchasing marine-grade resin rather than resin available at hardware stores, which contains a wax. This waxy surface will need to be sanded between cured layers. Expect to pay about $20 a gallon for a good quality layup resin. You may also choose to purchase additional MEKP if you want to mix your resin at a ratio higher than 1%. I also recommend purchasing a squeeze measuring container for the MEKP. Mixing cups and stir sticks will be needed to mix the resin and hardener. I recommend both 1 and 2.5 quart size plastic cups. They are widely available and cost about 50 cents each. They can be reused several times when working in straight fiberglass resin. Body filler and resin mixtures can only be used once. A mold release agent will be needed to keep the resin from sticking to surfaces. I use several release agents depending on the application. For duplicating kick panels, I use McGuire's Mirror Glaze Mold Release Wax. For spare tire well enclosures, I use plastic drop cloths in conjunction with aluminum foil and regular cooking spray. There is also a sprayable release agent called PVA, which stands for polyvinyl alcohol. It works very well, but the time it takes to set up and clean up is often more than the other methods. It's also a lot messier. A black permanent marker will be used for marking out a mounting surface and for highlighting a cut line on transparent fiberglass pieces. We'll use standard chip brushes for applying our resin. I recommend picking up the 2-inch brushes for most work. They are sold individually and by the case of 24 or 36. I'd recommend picking up a case since they are relatively inexpensive. Latex gloves are an absolute necessity. These protect your hands from the very sticky resin and body filler. Resin is almost impossible to wash off and burns to your skin as it cures. Gloves are sold by the 100 box and are about $7. Acetone is about the only thing that will remove polyester resin and can be a real lifesaver when cleaning up spills and tools. It's about $8 a gallon and is highly recommended. A hydrocarbon rated fume mask is another highly recommended item and is an absolute necessity when working in confined spaces such as the trunk. It filters out the very strong fiberglass resin odors, which can also be dangerous. $20 will get you a good quality mask. A fiberglass roller can be a very useful item for removing the bubbles that often appear between layers of fiberglass. This is especially true of large flat areas. Expect to pay about $5. Body filler is another staple of fiberglass fabrication. Body filler adds a lot of strength to projects and also makes a great material for filling in large gaps. There are several brands available, but the one I use is Rage Gold from Evercoat. It's about $20 to $25 per gallon and is available at auto body repair suppliers. If you don't have a center in your area, you can order it through the mail, or you may be able to talk your local auto body shop into ordering it for you. I also use a fiberglass reinforced body filler called Duraglass. There are also other brands available such as Marglass and Kitty Hair. These fillers are a little more expensive and run about $30 per gallon. They do add more strength because of the fibers, but are also more difficult to work with. To shape the body filler, we use simple plastic spreaders. As it begins to harden, we use a body filler shaper blade to take down the high spots. To sand our fiberglass and harden body filler, we use a variety of sandpapers. The most commonly used grits are 40, 80, 220, and 400. The lower the number, the more coarse the sandpaper is. The smoother the finished enclosure covering, the higher sandpaper you'll eventually need to use. When sanding items, it's important to wear a dust mask to keep from breathing in fiberglass fibers and body filler dust. A simple paper mask is better than nothing, but a better quality mask is recommended. The fume mask can be used, but I'd recommend purchasing different filters for sanding. The higher quality hydrocarbon filters will plug up very quickly if used for sanding. When sanding fiberglass or fiberglass reinforced body filler, it's important to protect your exposed skin. The small fiberglass fibers get everywhere and will cause you to itch like crazy. To help prevent these fibers from attaching to your skin, you can coat it with talc or baby powder. You can also wear a Tyvek suit, which is recommended for extensive sanding. These are about $6 and can be reused several times. Let's begin with a discussion about fiberglassing. Fiberglass work in car audio has been around for many years, but it's only been in the past several years that it's really evolved into a major portion of the custom work done. We see more and better fiberglass work as more installers learn to work with it. This growing expertise has given rise to the more advanced shapes and installations in vehicles ranging from top competition winners to everyday drivers. What was once a skill possessed by a few top installers has now become more and more a necessary skill for all installers. By learning to work with fiberglass, you'll be taking your skills to the next level. One of the first things you learn when working in the fiberglass arena is that you won't always use actual fiberglass. Many times other cloths will be used in conjunction with polyester resin to form the desired shape, and fiberglass cloths will not be used at all. These other cloths include grill cloth, trunk liner, felts, and fleeces. Knowing when to use each type of cloth will save you the time and expense of working with fiberglass. Automotive body filler is another product that you'll use extensively when working on your fiberglass projects. In fact, many of the materials you will use will come from the automotive or marine repair industries. One property of fiberglass that is important to remember is that fiberglass has more strength and curves than on flat panels. This is why we can make enclosures thinner than the 3/4 inch we would need if the enclosure was made from wood. It's also why we use MDF for any major flat areas on our projects. The three steps that almost all fiberglass projects have in common are the creation of a base, either wood or fiberglass, the formation of a frame, which will be wrapped in cloth, and the actual wrapping and resin application that will harden the wrapped structure. Look for each of these steps in the three projects we'll be demonstrating. Our first project will be a set of custom kick panels. These are one of the most requested items in a custom installation. They allow the front speakers to be placed in a more ideal mounting position compared to a door or dash installation. They also add a custom look to the install, which can be further enhanced with materials such as vinyl and paint. They require very little material to create and can be a good source of profit. They can also be created relatively quickly once you learn how to work with various materials involved. Let's get started. First thing we need to do is create a base for our panels. There are two main options to consider. The first, and the one I prefer, is to use the factory kick panel or a fiberglass copy of it. The other is to build a base around the floor of the vehicle. I prefer the factory kick panel for several reasons. First, it gives an easy fit and the factory look to the custom panels. Second, it doesn't require that the factory floor mats be customized to fit around the kick panels, and also leaves full legroom for the passengers. This is the method I will concentrate the demonstration on, but for completeness I'll first show how to build a fiberglass base without the factory kick panel. First, decide how much of the kick panel area you want to cover with the new pods. Do you want to include the area of the factory kick panels, or do you want to work around them? Once this decision is made, you need to add 2 layers of tape to the area you have chosen. I recommend a good quality 2-inch masking tape. I prefer the 3M brand. Start at the bottom of the area and work your way to the top, overlapping the layers by 1/3 to 1/2 the tape width. Doing so will ensure that any resin on the tape will not run between the overlapped layers. Once the tape is added, you'll also want to add a protected area around the main area with plastic drop cloth or aluminum foil. This is to protect the vehicle interior from accidental drips. Then use a permanent marker and draw out the area of the actual pod. When the fiberglass and resin are applied, the marker will stick to them and give an easy-to-see line that will be used as a guide for trimming. Now that the area is prepared, you can add strips of fiberglass mat and soak it with the fiberglass resin. You'll definitely want to wear your fume mask when working in the kick panel area. Also be sure to open up all of the vehicle's doors so that the fumes can escape. Ensure that all areas of the marked line are covered, and use caution not to drip resin outside of the taped area. When the resin has dried, peel off the fiberglass and remove the tape and foil from the interior. Keep the doors or windows of the vehicle open to allow the rest of the fumes to escape. Now take the fiberglass piece and trim it along the transferred line, and you'll have your base. Double check the fit and you're ready to begin framing and wrapping the piece. These techniques will be demonstrated on the factory kick panel based pods. Here you can see the plastic factory kick panel after it has been removed from the vehicle. We could use this panel, or if the owner wants to keep the factory panels, we can create a duplicate out of fiberglass. First, cut pieces of fiberglass mat for each panel to be duplicated. This should be large enough to cover the panels and to stretch around the curved areas. Use several layers if using a thin mat. Here I am using 2 layers of 1.5 ounce chop mat. I've also cut several small squares that will be used to fill any missing areas. Second, use a mold release wax and coat the factory panel with it. If your factory panel is carpeted or covered in a material other than plastic, then you'll want to tape it up first to protect these surfaces, then wax the tape. You'll need to wear your latex gloves for the rest of the process. You may also want to wear your safety glasses or goggles to prevent splashes from getting into your eyes. Using the plastic mixing cup, resin, and MEKP hardener, mix up enough resin, about 4 ounces per panel, at a 1% hardener to resin ratio. I'm using a graduated mixing cup and an MEKP dispenser to assure accurate mixing. Using a 2-inch chip brush, begin applying the mixture to the mat on top of the factory panel. Soak the mat until you can clearly see the factory panel. Apply to the entire panel, paying special attention to the curved areas. Pull the soaked mat around the curves if necessary. If this causes some areas to lose mat, add the small repair squares cut out earlier. Be sure to push in any factory screw holes so that the factory screws can be used to hold the new panel in place. Add the second layer of mat and repeat the process for the other panel. Push out any air bubbles by poking the mat with the brush tips. This is called stippling. To hold the soaked mat in place on the curved areas, add a strip of aluminum foil to the edge and clamp it using several clothespins. The aluminum foil will keep the clothespins from bonding with the fiberglass resin so that the clamps can be easily removed when dry. When all areas are covered with the mat and the clamps are in place, the piece can be placed on a small pedestal to avoid putting the fiberglass and resin onto a working surface. Here I am simply using a spare 1-quart plastic cup. Place your brush into a container of acetone to clean the brush and keep the resin from drying to the bristles. The brush can then be reused. While the panels are drying, we can create the mounting rings for our speakers. We'll be creating 2 rings, one for mounting the speaker, and the second ring will be used on top of the first. The second ring will be used to flush mount the speaker into the new pod. We'll create both of these rings with a plunge router and a circle jig. Here you can see the circle jig mounted to the base of the plunge router. A 1/4-inch straight cutting bit is used to cut out the rings. Keep in mind that this circle jig and its markings are calibrated for cutting holes, and so the outside diameter of the cut is what is marked out. If you want to cut out a 6-inch ring or disc, you'll need to set the circle jig cut out 6 1/4-inch hole. Here we're using an MDF top work surface and drill an 1/8-inch hole in to accommodate the 1/8-inch pin being used as a point of rotation. Next, take 2 pieces of wood large enough to create the rings and drill 1/8-inch holes in them. This will be the center of the ring. I'm using scraps of wood cut from larger woofer openings. We want our flush mount ring opening to be large enough for the woofer grill, plus the material we'll use to wrap the pod. We'll also want it to be about 1/2 inch in width. Since our grill is 6 inches wide, we'll make the inner opening 6 1/8 inch, and the outer diameter will then be 7 1/8 inch. The bottom mounting ring will be 7 1/8 inch in diameter to match the flush ring, and the inner opening will be our speaker mounting hole diameter. You'll definitely want to wear your safety glasses and probably hearing protection for this process. Begin by cutting out the 7 1/8 inch outside diameter for both rings. Set the pin into the circle jig at the 7 3/8 inch mark, and then place the pin through the ring material and into the hole in the MDF top of the work surface. Set the depth on the plunge router to a little more than half the material thickness. Turn the router on, plunge and lock the bit in place, and rotate the router around the center pin. When the entire diameter has been cut, turn off the router and return the plunge to its unlocked position. Flip the ring material over and repeat the process for the other side. After the outer diameters of both rings have been cut, move to the inner diameters. Set the flush trim ring inner diameter to 1 inch less than the outer diameter and repeat the cut process. Set the mounting ring inner diameter to the speaker mounting hole diameter and repeat the cut process. We'll also make a third piece at this time that has an outer diameter slightly less than the inner diameter of the flush trim ring. We'll be mounting a common laser pointer inside this piece to help us get proper imaging for the baffles. To make the piece sit flush in the baffle, we'll wrap it in tape until it fits snugly. Now remove the piece and drill 3 holes in the baffle, one in the center large enough to mount the laser pointer. The other 2 holes will be used to pull the piece out of the baffle. It's very important that the middle hole is centered and drilled at a 90-degree angle to the baffle. Use a drill press or your plunge router to make this hole. Finally, insert the laser pointer in the middle of the hole. Again, wrap it in tape to get a snug fit. With this piece in place, we'll be able to tell exactly where our kick panel pod is aiming. After all rings have been made, you will want to soften the hard edge of flush trim rings by using a roundover bit. Here we've set up a small router table with a 3/8 inch roundover bit. Adjust the bit so that its bottom blade is flush with the table. Then turn it on and add the rounded edge to one side of the flush trim ring. Now drill the holes for the speaker to mount to on the mounting ring. Finally attach the 2 rings together. I'm using CA glue for these rings. Next, cut out 6 strips of 1 inch wide MDF. These will be used to prop up the mounting rings on the fiberglass base we are creating. Make each stilt about 6 inches long. These will later be trimmed down. We'll use 3 stilts for each panel. By the time these tasks are completed, the fiberglass should be cured. You can tell when the curing is complete because the piece will no longer give off heat. Test the stickiness of the fiberglass with your glove to see if it is safe to handle. If it is, then you can remove the clothespin clamps and aluminum foil from the piece. Take a black permanent marker and trace out the border of the factory panel. Remove the fiberglass mold from the panel. If any resin leaked onto the plastic panel, it can be wiped off with acetone and a rag. You can also remove the excess resin from the plastic cup so the cup can be reused. Press along the edges of the cup to break the resin free from it. Once the resin is free, you can slam it upside down onto your work surface, and it should pop right out. Remove any stray pieces of resin from the cup and it's ready to reuse. Now cut out the fiberglass piece along the marked line. Be sure and coat your exposed skin with talc to prevent fiberglass strands from sticking to it. Here I'm using an air body saw to cut out the piece. You could also use a Dremel or rotozip type tool with a spiral cutting bit. When the cutting is complete, you'll have a near perfect copy of the factory panel to use as your project base. Now we have our base, rings, and 1 inch mounting stilts. Our next step is to add the stilts to the base and ring combination. But to do this, we'll need to make sure we mount the rings with enough depth for the speaker and at the proper angle for good imaging. Place the fiberglass panel copy in place of the factory panel in the vehicle. Place the laser pointer piece into the baffle and take the combination to the vehicle along with the mounting stilts and a black permanent marker. Now aim the baffle so that it is pointing at the vehicle's dome light. You may want to have a partner help you with this. Then take one of the stilts and place its outer surface against the ring and mark the line and the angle you'll need to add to the end. Repeat for the other 2 stilts. Remove the panel, rings, and stilts and move them back to the work area. Cut the stilts to the proper length and angle using the marked line as a guide. Then attach them to the base and rings using hot glue. CA glue forms a better bond, but hot glue fills in small gaps better. Once the pods are completed, the stilts will not add any significant strength to the structure, so either glue will work. When the stilts are in place and the glue is dried, it is time to double check the mounting angles. Take the structure back to the vehicle and make sure that the angles are correct. If they're not, then break loose and adjust the stilts as necessary. This can take many tries to get right, so try not to get frustrated. When everything is okay, then we're ready to begin wrapping. To wrap our base and frame, we'll need to use a non-fiberglass cloth. We can't use fiberglass mat or cloth because it will sag and fall apart when the resin is applied to it. So first we wrap with any number of cloths. The thinner and stretchier the material, the better it will conform to curves. Common cloths from thinnest to thickest are grill cloth, trunk liner, fleece, and felt. Kick panels are a good place to use the thinner materials. Here I'm using a polyester fabric called PK knit. It's similar to grill cloth and is semi-stretchable, but at half the cost. It's available at most fabric stores. Now cover the speaker hole opening with masking tape. This will prevent excess resin, trimmings, and dust from getting inside the pod. Then begin the stretching process by spraying the backside edge of the fiberglass panel with spray adhesive. Flip the piece over and drape the cut cloth over it. Then begin the process of pulling and pressing the fabric to the sticky edge on the back side. The idea is to create a form-fitting exterior with no wrinkles or sags that we can apply a layer of resin to. When the wrapping is complete, it's time to apply the resin. Mix up another batch of 1% resin as before and apply it with the paintbrush to the stretched fabric. Do not apply resin to the backside of the cloth or the spray glue will release and you'll have to re-wrap the piece. Only brush resin up to the edge of the panel. Cover the entire front of the piece with resin, including the area in the middle of the ring. This will need to be stiff so that it can be easily cut out later. Place the piece back on the stand and place the brush back in the acetone. Let the resin cure. The resin is cured when the exterior is stiff and no longer sticky. When this happens, you're ready to begin strengthening the enclosure. We could add fiberglass mat at this point, but it's not necessary since we'll be using body filler to fill in the gaps and smooth out the pod. The body filler will give us the extra strength we need. You'll want to wear latex gloves for this as well. First, give the resin a quick sand with a rough grit sandpaper. Nothing extensive, just enough to remove the shine and give the body filler a better surface to adhere to. Then begin scooping out and mixing the body filler with hardener on a piece of scrap MDF. I use a plastic spreader to mix and apply the filler. Rage Gold is yellow and uses a blue cream hardener. When they are properly mixed, the result will be a pale green. Be sure to mix thoroughly since any unmixed body filler will not cure and leave soft spots. Once the body filler is mixed, it will begin to harden, so you'll need to work quickly. Use the plastic spreader to apply and roughly shape the body filler to the pod. Look for major gaps and areas that need extra attention as you rotate and apply filler to the piece. When you're satisfied with the coverage, you can place the piece back on the pedestal. Now keep a close eye on the body filler to see when it begins to stiffen up. This is when you will be able to take down the high spots in the filler using your shaper blade. If you wait too long, the body filler will be very difficult to work with. If you shape it too soon, the form will lose shape and the blade will clog up with filler. Test the high spots with your gloved finger to see if it is stiff enough to work. Again, you'll need to work quickly, so don't spend too much time in one particular area. Run the blade over the top of the high spots and the filler will come through the blade like cheese through a cheese grater. When the rough shaping is complete, you can put it back on the plastic cup and wait for it to cure. Because of the short curing time of the body filler, I would recommend only mixing enough filler to do one panel at a time. While the first panel is curing, you can begin the work on the second panel. Once the curing is complete, you can further shape the filler by sanding. Use a rough grit of 80 or below to further remove the high spots and give the panel more shape. You can do this by hand or use a power sander, either electric or air. I prefer to use an angled die grinder with a small sanding disc. For first-timers, I'd recommend you do at least some of the sanding by hand. This will give you a better feel of how the piece reacts to the sandpaper and how much pressure and time you'll need to spend on each area. This is invaluable experience. You'll notice here that we've sanded through the body filler in some places and have small gaps in other areas. We'll remedy this by adding more body filler, but instead of spreading it on, we can mix it with fiberglass resin and either brush or pour it on. For these kick panels, I'll demonstrate how to make a mixture that can be poured on. This is something you'll want to wear gloves for. Begin by taking a plastic mixing cup and filling it with body filler. About 4 to 6 ounces should do for each panel. Then add an equal amount of fiberglass resin to the mixture and stir it thoroughly. When the mixture is properly mixed, add enough MEKP hardener for a 1% ratio, as if the entire mixture were pure resin. So if you mixed up 8 ounces of mixture, then you'll need to add 2.5 cc's of MEKP. You do not need to add the cream hardener, though I've done it both ways, and find a little difference. You'll want to experiment for yourself. Start the pouring on the far curved side. Cover that side well, and then place the kick panel pod onto the plastic cup pedestal. Then starting from the inside of the flush trim ring, pour the mixture evenly over the entire surface so that the mixture runs off the pod, making sure that all areas are covered by the pour. This pour will fill in the small gaps and low areas while giving us a surface that is much smoother than we would normally get with straight body filler. Once this is cured, we can begin the final sanding process and smooth the pod as much as necessary for our final covering material. The smoother the final surface, the more we'll need to sand it. Carpeted pods will work well with only an 80 grit sanding. Vinyl cover surfaces should be smoothed to a 220 finish. Painted surfaces will need to be nearly flawless with a 400 grit or higher finish. I would recommend that you do not try to paint your first kick panels until you have more experience. Any imperfections will show up in the paint and ruin the final look of the piece. Once sanding is complete, it's time for a final trim. Flip the piece over and cut away the excess cloth with a razor knife. Then cut out the speaker ring so that the speaker can be mounted. Here I'm using an air power die grinder with a flush trim bit to do the job. A Dremel or rotozip type tool with a spiral cutting bit will also work. Begin by drilling a pilot hole in the top surface and then run the cutting tool along the inside edge of the piece to trim the piece flush. Here I've completed a second pod without first taping the speaker hole opening to show what kind of junk can get inside the pod. Notice the small shavings that have lodged inside the pod. Over time these will come loose and could possibly damage the voice coil of the speaker. This is why we spend a few seconds taping off the speaker opening. Now we do a final check of the fit in the vehicle. Everything looks good, so we'll call it a success. Now we're ready to turn a regular subwoofer enclosure into something more eye-catching. Here we've created 5 sides of a 6-sided enclosure out of MDF. So far it's the beginning of a basic enclosure, but with a little fiberglass work we can turn it into something worth looking at as well as listening to. We begin the process in a similar manner to the kick panel pod. First we start with a base. This is our MDF enclosure. Then we add a frame for cloth to be stretched over. We create a set of mounting and flush trim rings exactly as we did for the kick panel pods. We mount them above the enclosure using the 3 stilts as before. We could angle the mounting ring out or in, but we'll leave it flat for this enclosure. If you're building an enclosure with multiple woofers, you'll probably want to angle the woofer either towards or away from each other for a more stylistic approach. Once the rings are mounted to the stilts, we can begin the wrapping process. We'll be using fleece, specifically polar fleece, for our wrapping cloth. It is both more stretchable and holds more resin as compared to the thinner grill or knit cloth. Notice that the cloth is much stretchier in one direction. We want the stretchy direction to be oriented in the direction we'll be pulling the cloth. Begin by spraying a ring of adhesive around the perimeter of the enclosure. Then attach the cloth to one side and pull it and attach it to the opposite side. This should be using the non-stretchy direction of the cloth. Now pull the cloth to the 2 remaining sides so that the cloth is tight and all wrinkles are removed. This should be done using the stretchy direction of the cloth. In order to form a strong bond with the enclosure, we need to staple the cloth to the top of the enclosure. Use 1/2-inch long staples and place them along the enclosure perimeter 1/2 inch apart. This is the correct way to do it. However, I'm going to demonstrate why you need to staple the cloth down by creating the enclosure without staples. I'll also show you how you can still salvage the piece if you forget or are unable to use the staples. Once the cloth is in place, you can mix up and apply resin to the fleece. You'll need to use much more resin for the fleece as compared to the knit cloth. This is because of the much greater thickness of the cloth and its ability to soak up resin more effectively. Again, do not brush resin onto the glued area of the cloth. Only brush it up to the edge or the glue will release. When the resin has cured, the piece will be very stiff because of all the resin used. For large high-powered enclosures, you may want to add layers of fiberglass mat, but usually you only need to use the fleece. It doesn't hurt to add the extra layers, but does take extra time and money to complete the project. Instead, you can use a fiberglass reinforced body filler. Here I'm mixing up some Duraglass to apply to the enclosure. It's similar to regular body filler, but is a little stiffer and harder to work with. As before, add the hardener and mix it thoroughly. Then apply it with a plastic spreader and wait for it to cure enough that it can be shaped with the body filler blade. After the piece has cured, you can begin the sanding process as before. When sanding fiberglass reinforced body fillers, you'll need to protect your exposed skin with talc. As you sand the filler, the fiberglass strands will come loose and attach themselves to your unprotected skin. Once the enclosure is rough sanded, it is ready for a second coat of regular body filler. We will not be able to pour the mixture on as before because the excess will run all over our enclosure and cause a mess. Instead, we'll want to create a mixture that can be applied with a brush. Instead of a 50-50 mixture, I usually do a 1/3 resin to 2/3 body filler ratio. What you're shooting for is a mixture that is thin enough to paint without being so thin that it runs off the enclosure. You also want it thin enough that the brush strokes will disappear as you apply it. Mix up the resin and body filler mixture in the cup, and then add the MEKP hardener like we did for the kick panel pods. Once combined, begin painting the mixture to the top of the enclosure and work your way down in sections, eventually coming back to the starting point. Notice that the extra cloth acts as a drop cloth for some of our small drips. Once the mixture is cured, we can pry the top from the enclosure. Here we can see why the top came off so easily. There is very little bond between the fleece and the MDF enclosure. This is why we need to add staples to increase the surface area of the bond and add a mechanical fastener to the piece. But we can still salvage this piece. First we'll need to trim the top using a body saw or electric cutter with a spiral cutting bit. Next we mix up some regular body filler and apply it to the top surface of the MDF enclosure. Once all edges have a generous portion of body filler, we can set the formed top into it. This will bond the two pieces together. If there are any gaps between the two pieces, we can apply body filler to the gaps. This can then be sanded flush for a perfect fit. Finally, we cut out our speaker hole using a flush trim or spiral cutting bit and sand the enclosure as needed. Here you can see how different levels of sanding will give different degrees of surface perfection. We have an unsanded section, a section sanded with 80 grit, one sanded with 220 grit, and one sanded with 400 grit. Each is a little smoother than the last, with 400 grit being ready for paint. Our final project will be the construction of a spare tire well enclosure. This is a very popular installation technique when trunk space needs to be maximized, or the owner wants an ultra-stealth installation. Here the subwoofer will use the space normally occupied by the spare tire. The biggest drawback to this method is that the spare tire needs to be removed and won't be available in an emergency. Make sure the owner is aware of this before proceeding. The first step in this installation is the removal of the trunk carpet, wheel well baffle, and spare tire. Some spare tire wells will have large threaded bolts sticking up from the bottom that will probably need to be removed before beginning the installation. This vehicle has a small bump that a threaded bolt screws into. We could remove this, but it's so small that we can work around it. Just make sure that there is enough depth to mount the subwoofer if a flush installation is desired. After the extra items have been removed and the wheel well has been vacuumed out, it's time to start laying down our protective surface. This is to prevent excess resin from getting on the trunk surfaces and to keep the fiberglass resin from sticking to the spare tire well. I'm laying down a large drop cloth as our secondary level of protection. Our primary level of protection will be a layer of aluminum foil that is form-fit into the well. Be sure to tape the seams between sheets to prevent resin leak-through. When all taping is complete, we add our mold release. A simple kitchen cooking spray works very well and is easy to apply. Now we can prepare our fiberglass mat. I'm using a 3-ounce chop mat that comes in a 4-inch wide roll. Cut several lengths that will cover the width of the well. Cut one set for each layer you plan to add, and also cut some square patches. Once the mat is ready, we can mix up the resin. This is definitely a job you'll need to wear a fume mask for, since the vapors will be concentrated in a very small area. Be sure and open the doors or windows of the vehicle to let the resin fumes escape the interior. Now put on gloves and mix up 1 liter of resin at a 1% resin to hardener ratio. Once thoroughly mixed, begin saturating the chop mat 1 layer at a time. Saturate the mat until it becomes transparent. Be sure and saturate the mat at least 2 inches past the top edge of the spare tire well. We'll need this lip to mount our baffle board to. When the first layer is complete, you can add a second layer of mat directly over the first layer. I wouldn't recommend adding more than 3 layers of mat at one time. Now let the fiberglass cure in the well with the trunk lid open. For the final layers, we'll be working outside of the vehicle. It's easier and eliminates the chance of spilling resin on the vehicle or in the trunk. It also lets the owner take the vehicle home for the night if they need it. Remove the tape where it attaches to the vehicle and simply pull the fiberglass tub out of the well. It should come out easily because of the plastic and foil layers. Now invert the tub onto your work surface and remove the plastic and foil. The cooking spray will allow the foil to peel off easily for the most part. You may get a few places that stick, but that's okay. They should come off with a little prying. Now we're ready to add our final layers. We could keep adding fiberglass mat and resin, but this is more expensive and time consuming. Instead we'll add a layer of core mat followed by another layer of fiberglass mat to keep it in place. Core mat is a chopped fiber polyester fabric that is used to thicken and strengthen the enclosure. It will save time, weight, and fiberglass when creating our enclosure. It also doesn't warp like an equivalent amount of curing fiberglass would, and the 4mm version is the equivalent of about 4 layers of fiberglass mat. Because core mat is so thick, we will need to pre-cut it to the curves of our enclosure. Keep the enclosure inverted and wipe off the cooking spray residue with a damp soapy rag. Dry it with a towel and add a light coat of spray adhesive to the top to make the surface semi-tacky. Now take a piece of core mat large enough to cover the enclosure and take into account the curved areas and place it on the inverted enclosure. Cut in from one edge until you reach the edge of the enclosure bottom. Move over about 6 inches and repeat the process. When all cuts are complete, you can flip the enclosure over and add another coat of spray adhesive. This one should be heavy enough to make the core mat stick to the enclosure. Then press the core mat to the bottom. Finally overlap the seams of the cuts and make a flush cut from the top to the bottom. Remove the 2 pieces of core mat that were cut out and press the seam in place. Repeat this for all other overlaps. Now pre-cut strips of fiberglass to lay over the top of the core mat. This is the same process we used for the first layers of fiberglass. When everything is laid and ready, you can put on your gloves and fume mask and mix up the needed resin. Core mat soaks up a lot of resin because of the thickness, so plan on using at least a half a gallon of resin for this step. You can mix the resin in 2 consecutive batches instead of all at once. This will increase your working time before curing. Begin by pouring a generous amount of the resin over the bottom of the enclosure and spread it around the enclosure. Use your brush to push the resin into the mat and to eliminate air bubbles using the stippling technique. I'm adding 2 layers on top of the core mat for extra strength. Once both layers are complete, use your fiberglass roller to remove any remaining air bubbles. Place your brush and roller in acetone and let the resin cure. Set the enclosure in the sun if possible to speed the curing time. After the enclosure has cured, cut the excess material away from the enclosure lip. The remaining piece will be what we mount our MDF baffle to. Place the trim piece in the spare tire well and double check for fit. Now place the inverted enclosure onto a piece of MDF large enough to cover the opening. Trace along the edge with a permanent marker. With the size of this enclosure's lip, it is necessary to trim another inch from this line. We'll also use a rabbiting bit to help the MDF baffle seat properly on the enclosure lip. Here you can see the gaps that exist between the enclosure form and the flat MDF baffle. We'll cover these with more fiberglass later in the process. Also note the alignment marks that were made to match the enclosure to the baffle. A total of 3 marks were made for matching. If we were using an MDF ring and wrapping in fleece, we would not need to bridge the gap with fiberglass or make an MDF baffle to fit. However, if we want a strong flat surface, we'll need to make a baffle from MDF. Before attaching the baffle to the enclosure, we'll cut out the subwoofer and terminal cut mounting holes and pre-drill the screw holes. For the speaker hole, we'll be using our router and circle jig again. The speaker hole will also be rabbited to flush mount the subwoofer. The terminal cup will be cut out with a plunge router. Adding a thin layer of sawdust to the surface will help the router glide more easily. To attach the MDF baffle to the fiberglass tub, we'll use construction adhesive. Since the 2 pieces do not meet in all places, we'll mark out on the baffle where they do meet. This is where we'll add a generous line of adhesive. The rabbited edge gives us more surface area for bonding. Be sure to wear gloves, as construction adhesive is not something you want on your skin. After the baffle is in place, add another line of adhesive to the outer edge. You are now ready for the fiberglass. Pre-cut 12 to 18 inch strips of fiberglass mat mix up about a half a liter of resin. Begin by painting a layer of resin to the MDF baffle edge and then place a strip of mat over it. Soak the mat with resin to bond it to the baffle and the fiberglass lip. Push out any air pockets with the brush. Make sure that the mat is attached securely to the baffle and the lip. Add a second layer of mat directly on top of the first layer. Once both layers are in place, move to the next section of the enclosure. When the entire enclosure edge is covered with 2 layers of mat, add a third layer of mat on top of this. Because this edge is curved, it will be very strong, and 3 layers is all we will need. After the resin has cured, we can go back and cut off the excess fiberglass along the lip edge. There will still be small holes along this edge, so for extra assurance we will mix up some more resin and apply it to the enclosure edge. Be sure to push the resin into the edge to make sure any small holes are filled. After the final resin application is cured, we can mount our hardware and check the final product. The enclosure fits perfectly into the spare tire well and disappears once the factory carpet is in place. Don't forget to add a grill to the subwoofer to protect the cone from objects placed in the trunk. That concludes this video. I wish you success with your own fiberglass projects. Have fun and good luck. To form a base for our projects, we'll need medium density fiberboard. This will be used to create the mounting surface for our speakers and also to form the base of our larger enclosure projects. Common 2x4 or 2x6 building material will be used to prop up the solid mounting surfaces. A power drill will be used for any screw holes in the wood. A plunge router will be used in combination with a circle jig for creating the rings and mounting holes for our speakers. The circle jig being used is the M200 from Jasper Audio. These are available directly from Jasper Audio as well as Parts Express. Fixed base router will be used in a small homemade router table to do any flush trim, round over, and rabbiting work needed. Plans for the router table I'm using are available on the internet. If you would like the plans, I have provided a link in the included documentation. We'll be using 4 different router bits. The 1/4 inch straight cut bit will be used with the circle jig to create the rings and mounting holes for our drivers. The 3/8 inch roundover bit will be used in the router table to take the hard edge off the flush mounting rings and amplifier rack. The rabbiting bit will be used to trim down the MDF so the cloth can be stapled flush. The 1/2 inch flush trim bit will be used to cut away the excess fiberglass from the mounting rings and MDF from our enclosure amp rack combo. A pneumatic die grinder will be used in conjunction with the 1/2 inch flush trim bit to trim away the excess material from the mounting rings. An electric unit such as a Dremel or rotozip could be used with a spiral cutting bit for this purpose. A body saw is also recommended for cutting the fiberglass to the needed shape after curing. Again, a Dremel or rotozip with a spiral cutting bit could be used. For the smaller areas that the flush trim bit is too large for, we will use a rotary cutting tool. This is a pneumatic model, but is similar to an electric unit. An angle die grinder will be used in conjunction with 3M roll-lock discs to remove excess material quickly. The 24 grit discs are shown here, but 36 grit will also work. Ask for 3M part number 01408. Expect to pay about $30 for a box of 25. To sand our fiberglass and harden body filler, we use a variety of sandpapers. The most commonly used grits are 40, 80, 220, and 400. The lower the number, the more coarse the sandpaper is. The smoother the finished enclosure covering, the higher sandpaper you will eventually need to use. These papers are used for hand sanding. I'll also be using a professional grade dual action or DA sander from Snap-on. This is a discontinued model, but other 3-inch DA sanders are available. Chicago Pneumatic makes one that can be purchased for about $90 new. The part number is CP7200S. The sandpaper being used with the DA is from 3M and is part of the Hook It Gold series. The discs come in various grits and have a Velcro backing that attaches to the pad of the DA sander. I'm using 80, 220, and 500 grit papers. Expect to pay about $25 for a box of 50 discs. When sanding, it's important to wear a dust mask to keep from breathing in fiberglass fibers and body filler dust. A simple paper mask is better than nothing, but a better quality mask is recommended. A fume mask can be used, but I recommend purchasing different filters for sanding. The higher quality hydrocarbon filters will plug up very quickly if used for sanding. When sanding fiberglass, it's also important to protect your exposed skin. The small fiberglass fibers get everywhere and will cause you to itch like crazy. To help prevent these fibers from attaching to your skin, you can coat it with talc. You can also wear a Tyvek suit, which is recommended for extensive sanding. These are about $6 and can be reused several times. A staple gun should be used to attach the cloth to the edge of the wood enclosure to ensure a strong bond. An air-powered model is recommended, but an electric or hand stapler will work if 1/2 inch staples are used. This gun is a professional unit from BEA and is preferred by many installers. Expect to pay about $200 for a top-quality new gun or $50 for a used model. A pair of scissors and a razor knife will be needed for cutting and trimming the polyester wrapping cloths that will be used. These do not need to be of a high quality, but they do need to be relatively sharp. A heavy-duty pair of shears needs to be used for cutting the fiberglass mat. I prefer to use a cheap pair from a dollar store rather than maintain a quality pair of shears. When the cheap ones wear out, I simply purchase another pair. Wood glue, drywall screws, and brad nails will be used to hold the MDF pieces together. An air brad nailer is highly recommended, though it is possible to use other methods such as gluing and clamping or gluing and screwing to get the same result. To form the first layer of our wrap shape, we'll need polyester-based cloth. Polyester is a good choice because it is stretchable and is the same material as our resin. Thinner cloths will be used for more complex shapes, and thicker cloths will be used for enclosure baffles. For these projects, we'll use polar fleece and plush felt. Both are 100% polyester-based materials. To temporarily hold the cloth in place, we'll use spray glue. I recommend Super 77 from 3M as a good all-purpose spray adhesive. Fiberglass mat will be used to form the base of our vehicle molds and can also be used to strengthen the polyester cloth. Mat comes in various thicknesses or weights and is sold by the yard. The most popular weights are 1.5 ounce and 3 ounce. The thinner the material, the more readily it will take resin and bend around curves. The thicker the material, the stronger it will be when cured. I recommend purchasing some of each. To saturate and cure our cloth, we'll need polyester resin and MEKP hardener. This is what will give our cloth strength when cured. Resin is sold by the gallon and usually comes with enough hardener to mix the resin at 1%. I recommend purchasing marine-grade resin rather than the resin available at hardware stores, which can contain a wax. Expect to pay about $20 to $25 a gallon for the good quality layup resin. You may also choose to purchase additional MEKP if you want to mix your resin at a ratio higher than 1%. I recommend purchasing a squeeze measuring container for the MEKP. To thicken the resin, we'll use fumed silica, which is a thixotropic powder. Common talc can also be used as a thickener, but is heavier if that's an issue in your projects. Mixing cups and stir sticks will be needed to mix the resin and hardener. I recommend both 1 and 2.5 quart size plastic cups. They are widely available and cost about $1 each. They can be reused several times when working in straight fiberglass resin. A plastic drop cloth will be needed to protect your work surfaces and to protect the vehicle from any resin drips. This is used in conjunction with masking tape to form the two most common methods of surface protection. A black permanent marker will be used for marking out a mounting surface and for highlighting a cut line on transparent fiberglass pieces. We'll use standard chip brushes for applying our resin. I recommend picking up the 2-inch brushes for small projects and 3-inch for larger ones. They are sold individually and by the case of 24 or 36. I'd recommend picking up a case since they are relatively inexpensive. Latex gloves are an absolute necessity. These protect your hands from the very sticky resin and body filler. Resin is almost impossible to wash off and burns your skin as it cures. Gloves are sold by the 100 box and are about $7. Acetone is about the only thing that will remove polyester resin. It can be a real lifesaver when cleaning up spills and tools. It's about $8 a gallon and is highly recommended. A hydrocarbon rated fume mask is another highly recommended item. It is an absolute necessity when working in confined spaces such as the trunk. It filters out the very strong fiberglass resin odors, which can also be dangerous. $20 will get you a good quality mask. A fiberglass roller can be a very useful item for removing the bubbles that often appear between layers of fiberglass. This is especially true of large flat areas. Expect to pay about $5. A silicone caulk will be used to seal up some of the wiring on the enclosure amp rack combo piece. Body filler is another staple of fiberglass fabrication. Body filler adds a lot of strength to projects and also makes a great material for filling in large gaps. There are several brands available, but the one I use is Rage Gold from Evercoat. It's about $20 to $25 per gallon and is available at auto body suppliers. If you don't have a center in your town, you can order it through the mail, or you may be able to tuck your local auto body shop into ordering it for you. To shape the body filler, we use simple plastic spreaders. This will form the body filler while it's still pliable. For filling pinholes and fine filler work, we'll use glazing putty. This is a lot like body filler, except it is much thinner and isn't prone to imperfections. Expect to pay $15 to $20 for a quart. To bond MDF to our plastic door panels, we'll need another type of filler because regular body filler isn't as compatible with plastics. The filler I'm using is 3M Rigid Parts Repair Epoxy, part number 05883 in the Auto Mix line. This is a 2-part epoxy that is basically a liquid plastic paste. The kit comes with 2 5-ounce tubes that are mixed together, and it costs about $25 to $30. There are other brands of rigid parts repair available, but this is the one my auto body supplier carries. To achieve a smoother finish for our painted projects, we'll be using a high build primer. This will be used before the paint is applied to fill in small pits and prep the surface for paint. There are several brands available, including Featherfill and Duratec. It's important to use a primer that is compatible with the paint you'll be using, so ask your supplier which kind you should use. Expect to pay about $25 to $50 per gallon. A commercial grade paint prep will be used to prepare our primed surface for paint. Tack cloths will be used as the final wipe down before spraying. Since we'll be doing some basic paint work, we'll need an HVLP, or high volume, low pressure spray gun with an air regulator and air dryer. I use a separate hose as well because the hose I use for other air tools has oil residue in it that I don't want getting into the paint. A decent paint gun will run about $50 and up, depending on the quality and features. To clean up the paint gun, lacquer thinner will be used with the cleaning brush kit. The paint that will be used is a single-stage acrylic paint from DuPont. This is a very basic equipment paint you can get from your auto body supplier. It's much easier and cheaper to work with than the more expensive paints that require activator and reducer. It's also of a lower quality, but is a great paint to start with. It's fine for interior pieces and it has a very high gloss that doesn't require a separate clear coat. The black being used here is Nason 414-1000 and is about $20 a gallon. To achieve a factory texture on the door panels, we'll be using 3M rocker panel spray. The part number is 05911 and is about $15 a can. To dye the texture surface, we'll be using Sem's Color Coat plastic and vinyl dye, which is about $10 a can. Simple rubbing alcohol will be used to prep the surfaces for the dye. Let's begin with a discussion about fiberglassing. Fiberglass work in car audio has been around for many years, but it's only been the past several years that it's really evolved into a major portion of the custom work done. We see more and better fiberglass work as more installers learn to work with it. This growing expertise has given rise to the more advanced shapes and installations in vehicles ranging from top competition winners to everyday drivers. What was once a skill possessed by a few top installers has now become more and more a necessary skill for all installers. By learning to work with fiberglass, you'll be taking your skills to the next level. One of the first things you learn when working in the fiberglassing arena is that you won't always use actual fiberglass. Many times other cloths will be used in conjunction with polyester resin to form the desired shape, and fiberglass cloths will not be used at all. These other cloths include grill cloth, trunk liner, felts, and fleeces. Knowing when to use each type of cloth will save you the time and expense of working with fiberglass. Automotive body filler is another product you'll use extensively when working on your fiberglass projects. In fact, many of the materials you will use will come from the automotive or marine repair industries. One property of fiberglass that is important to remember is that fiberglass has more strength and curves than on flat panels. This is why we can make enclosures thinner than the 3/4 inch we would need if the enclosure was made from wood. It's also why we use MDF for any major flat areas in our projects. The 3 steps that almost all fiberglass projects have in common are the creation of a base, either wood or fiberglass, the formation of a frame which will be wrapped in cloth, and the actual wrapping and resin application that will harden the wrap structure. Look for each of these steps in the 3 projects we'll be demonstrating. Our first project will be a trunk-mounted enclosure that's molded to fit into the rear corner of the trunk. These are very popular because they save a lot of space by utilizing an otherwise unused area of the trunk. This enclosure will be mounted in the driver's side corner of the vehicle, and it will extend out to meet the inner edge of the wheel well. The height will be a little below the bottom of the trunk lid weather stripping. You'll want to vacuum this area to remove any dirt and debris beforehand. Now that the area has been chosen, we tape it off with 2-inch masking tape to protect the area. I highly recommend using 3M brand masking tape because it gives a superior bond which helps prevent leak-through. It's not necessary to use the blue or green painter's tape, but stay away from the generic tape. I always use 2 layers of masking tape to ensure the resin will not leak onto the vehicle. Overlap the tape by 1/3 to 1/2 the tape width. Center the second layer of tape over the seams of the first layer. After both layers of tape are secured, draw out the final enclosure shape with a black permanent marker. If you have any straight lines, make sure they are drawn out with a straight edge. This will save you from having to fix it later, which takes unnecessary time. When drawing out the shape, be sure to take into account any moving parts such as this trunk lid hinge. Also remember that the enclosure will need to be removed from the vehicle, so don't make it so large that it won't fit through the trunk opening. Create your shape using smooth curved lines whenever possible. This gives the piece a neater look and makes it easier to wrap in cloth. Sudden, sharp angles are difficult to wrap and throw off the flowing look of the final piece. Here you can see the final shape that was drawn out. Notice where the lines are in relation to the vehicle. The final piece won't interfere with any of the vehicle functions or removal of the enclosure. After the shape has been drawn out, it's time to apply a fiberglass mat. Since our piece is vertical, we'll spray the tape with spray glue to temporarily hold the mat in place. I recommend cutting the mat in its strips to make it easier to work with. I buy rolls of 4-inch wide mat, which really speeds up the process. Keep cutting and pressing until the entire drawn out area is covered. It's a good practice to overlap the line to be cut by 1 inch to ensure adequate thickness in the cut line area. Once the area is completely covered, mix up 1 to 2 liters of resin at a 1 to 2% hardener ratio and begin soaking the mat using a 2 to 3 inch brush. A greater hardener ratio will speed the curing time, but will also decrease the working time, so mix according to your own experience and speed. Be sure to wear your fume mask when working in the trunk and wear your gloves to prevent resin from getting on your hands. Soak the mat completely through the tape by pressing the resin into the mat with a brush. Press out any air bubbles in the same manner. This technique is called stippling. When the first layer is complete, add additional layers of mat and resin as needed to strengthen the enclosure. The stickiness of the resin will hold the additional layers in place, so spray glue isn't needed after the first layer. For this type of project, a 6-ounce thickness is usually adequate, so if you're using 2-ounce chop mat, you'll need 3 layers. A 3-ounce mat will only need 2 layers, and so on. It's important that the fiberglass is strong so that it doesn't warp when the resin is curing on the wrapping fabric. When all layers have been applied, clean the brush in acetone and allow the piece to cure completely in the trunk. While this is curing, you can make the mounting ring for the woofer. We'll be creating 2 rings, one for mounting the woofer and a second ring that will be mounted on top of the first. The second ring will be used to flush mount the speaker into the enclosure. We'll create both of these rings with a plunge router and a circle jig. Here you can see the circle jig mounted to the base of the plunge router. A 1/4 inch straight cutting bit is used to cut out the rings. Keep in mind that this circle jig and its markings are calibrated for cutting holes, so the outside diameter of the cut is what is marked out. If you want to cut out a 10-inch ring or disc, you'll need to set the circle jig cut out a 10.5-inch hole. This allows for the thickness of the 1/4 inch router bit. Here we're using an MDF topped work surface with an 1/8 inch hole in it to accommodate the 1/8 inch pin used as a point of rotation. Next, take 2 pieces of wood large enough to create the rings and drill 1/8 inch holes in them. This will be the center of the ring. We want our flush mount ring opening to be large enough for the woofer grill, plus the material we'll use to wrap the enclosure. We also want it to be about a 1/2 inch in width. Since our grill is 10 3/8 inch in diameter, we'll make the inner opening 10 5/8 inch, and the outer diameter will then be 11 5/8 inch. The bottom mounting ring will be 11 5/8 inch in diameter to match the flush ring, and the inner opening will be our woofer mounting hole diameter of 9 1/8 inch. You'll definitely want to wear your safety glasses and probably hearing protection for this process. Begin by cutting out the 11 5/8 inch outside diameter for both pieces. Set the pin into the circle jig at the 12 1/8 inch mark, and then place the pin through the ring material and into the hole in the MDF top of the work surface. Set the depth on the plunge router to a little more than half the material thickness. Turn the router on, plunge and lock the bit in place, and rotate the router around the center pin. When the entire diameter has been cut, turn off the router and return the plunge to its unlocked position. Flip the ring material over and repeat the process for the other side. After the outer diameters of both pieces have been cut, move to the inner diameters. Set the flush trim ring inner diameter to 10 5/8 inch and repeat the cut process. Set the mounting ring inner diameter to the woofer mounting hole diameter and repeat the cut process. Only cut through half the material when routing out the mounting hole diameter to keep the piece a solid disc while at the same time making it easier to cut out in the final steps. Now assemble the 2 pieces together using wood glue and brad nails. The strength comes from the glue, but the brad nails will hold them together while the glue dries. Use brad nails that are about 50% longer than the material being nailed when creating the rings. So for 3/4 inch MDF, you'd want to use 1 1/8 inch brad nails. This will ensure a strong bond without being so long that the nails protrude through the second piece. After all rings have been assembled, you'll want to soften the hard edge of the flush trim rings by using a roundover bit. Here we've set up the router table with a 3/8 inch roundover bit. Adjust the bit so that its bottom blade is flush with the table. Then turn it on and add the rounded edge to one side of the flush trim ring. Don't worry about the brad nails damaging the bit, because the carbide of the router bit will power right through the cheap steel of the nails. The pieces are now complete and ready for assembly. After the fiberglass base has cured, remove it from the vehicle. The tape will come off easily in the final stages of the curing process, because the heat from the resin curing will have softened the tape adhesive. Otherwise, the tape will not come off as readily. Most of this will not be a problem except around the edges of the enclosure, where we'll need to attach the fabric and carpeting for the enclosure. If you can't peel this area off by hand, you can use a sander to remove it. After the tape has been removed, you can cut out the enclosure shape along the marked line using the air body saw. Be sure to protect your exposed skin with talc and wear a dust mask because the cutting process will send small fiberglass fibers into the air. The edge can be smoothed with an angled die grinder and a 24 grit roll-off disc. Check the fit of the enclosure in the vehicle and trim if needed. Now decide where to mount the woofer ring in relation to the enclosure. I like to have the woofer ring protrude slightly from the enclosure bottom to give a smooth look. Measure the depth from the base of the fiberglass to the outer edge of the enclosure bottom. Cut a length of 2x4 to this length and mark an X to find the center point of the 2x4. Then attach the woofer base using a single wood screw through the router pivot point. Unless you have a perfectly flat mounting base, you'll have a gap between the 2x4 and the base that needs to be accounted for. This can be overcome by using a resin paste. To create this, mix up a small quantity of fiberglass resin and thixotropic powder until it forms a thick paste that can be used to bond the 2x4 to the base. Do not add the MEKP until you're ready to use the mixture. Now use some pieces of scrap MDF to prop up the ring to the desired height. The top scrap piece should be a ring so that the woofer mount won't want to roll off the props. Finally, add the MEKP to the resin paste and apply generous amounts to the base of the 2x4. The paste can be mixed hot with a 4 to 5% hardener ratio to ensure fast drying. Place the mount on the props and against the fiberglass base. Then add more resin paste to the two pieces to strengthen the bond. Use the small level on the 2x4 if you want to ensure the piece is drying level. The bond should dry in about 10 minutes and then the enclosure can be removed from the vehicle for wrapping. We'll be using plush felt for wrapping this enclosure because it is a very thick polyester-based fabric that is somewhat stretchable. Using a thick fabric like this will eliminate the need to strengthen the enclosure with multiple layers of fiberglass mat, which saves time and money. Begin by cutting a piece of fabric large enough to cover the front of the enclosure with at least 2 inches of overlap on the sides. Then spray the back side of the enclosure along the edge and allow it to tack up. Spray the edges of the felt with glue in the area it will bond with the enclosure. Plush felt has a smooth side and a rough side. Face the smooth side out to reduce finish time later on. Now drape the cloth over the enclosure and press one side in place. Then starting on one side, pull the fabric semi-tight and press against the enclosure back. When pulling, do not pull so hard that the piece warps. Only pull it tight enough to eliminate sags in the fabric. Continue this process of pulling and pressing until the fabric is taut over the enclosure. When the wrapping is complete, you can begin applying resin to the enclosure. Mix up 1 to 2 liters of resin and apply it to the fabric with a 3-inch brush. Pay special attention to the area of the MDF trim ring and the enclosure edges. The resin will bond the fabric to the MDF ring, so really soak this area well. Do not apply resin past the enclosure edge or the spray glue will release and the fabric will pull up. Keep applying resin until the fabric is completely saturated and the resin no longer soaks into the fabric. When completely saturated, the resin will begin to pool on the surface. Let the enclosure cure and clean the brush in acetone. After the resin is cured, it will be tack-free and no heat will be given off from the curing process. The piece is now ready for trimming and finishing. Begin by cutting out the fabric from the inside of the trim ring using a die grinder and flush trim bit or a rotary cutting tool. Drill a large enough hole for the bit to pass through, and then run the bit along the inner edge of the trim ring to get a perfectly flush cut. Now use the angled die grinder and roll-lock disc to remove the high spots from the enclosure and give a better surface for the carpet and body filler to adhere to. Any shiny spots in the surface will not bond well with the body filler or with the carpeting. Mix up a small quantity of body filler and apply to any low spots on the enclosure surface. This enclosure has a dip in it where there was a fold in the fabric. For dips such as this, apply a large quantity of filler to the area and then smooth it with a plastic spreader. Work across the dip and not with it, or else your spreader will follow the contour and the dip will remain. Once the body filler has hardened, the roll-lock disc can be used to bring down the excess filler. Run your hand over the enclosure to feel for any high spots in the surface. Since this enclosure will be wrapped in carpet, we can stop with the roll-lock disc. If another material is being used, such as vinyl or paint, we need to continue sanding with the DA sander and increasingly fine grit papers. Now that the sanding is complete, we can cut out the woofer mounting ring. Start by drilling a hole in the area of the previously cut line large enough for the air saw bit to pass through. Then run the saw blade along the cut line until the piece is completely free. Remove the center screw and then remove the 2x4 by tapping it. Flush the fabric with the fiberglass base using a roll-lock disc and the angled die grinder. This will help keep the piece flush with the vehicle. Then mark out the location for the terminal cup on the rear of the enclosure. I'm using an MDF template which I make for the most commonly used terminal cups. Finally cut out the area with an air saw or rotary cutting tool. Finish off the process by cleaning out the enclosure with a shop vac to remove any large debris from the interior. To further strengthen the enclosure, we'll apply resin mixed with thickener to the reverse side of the fabric. This will soak into the fabric where the first resin application didn't reach. Mix up some more of the resin and thixotropic powder as before. Don't mix the first layer too thick or it won't soak into the fabric. Pour some of the mixture into the enclosure and press it into the fabric with a brush to get better saturation. Spread it around the interior until the fabric is completely covered. Then you can mix some more thickener into the resin for a final thicker layer. The weakest part of this enclosure is the area between the fiberglass base and fabric, so pay special attention to this seam. This also seals any small air leaks and is similar to caulking an MDF enclosure. Here's what the finished layer looks like. You may need more or less depending on your choice of wrapping material. Now flip the enclosure over and cement the terminal cup in place using more of the resin paste. You can probably add more thickener to the same mixture used on the interior of the enclosure. Spread it around the opening for the terminal cup and press the cup into the paste. Then use a rag to clean any excess mixture from the enclosure. While this is drying, the enclosure can be wrapped. Begin by laying out the screw pattern for the woofer using the woofer or the grill ring. Then pre-drill the holes with an 1/8 inch bit and a power drill. Carpeting the enclosure will be similar to the wrapping process used before. Begin by spraying the enclosure and the carpeting and allow them to tack up. Then press one side in place and begin pulling and pressing the carpet onto the enclosure. Most box carpeting is stretchier than plush felt, so it should be relatively problem-free. Respray areas as needed and continue pulling and pressing. Carpet the woofer opening by first stretching the fabric slightly with your fist in a circular motion. Then cut slits into the center of the mounting ring to make it easier to press the carpeting into the flush trim ring area. Trim the excess carpet away with a razor knife by running it along the woofer opening. Then move on to the enclosure edges. Respray the edges and press firmly to hold them in place. Any excess can be trimmed with a razor knife. Before mounting the woofer, we'll need to cut the carpeting away from the screw holes. This keeps the carpet from wrapping around the mounting screws. Then to complete the enclosure, add fiber fill if desired, connect and mount the woofer, and add the grill. The enclosure can now be press fit in place, or strips of male Velcro can be added to the enclosure to secure it in the trunk carpeting. Our second project will be a combination enclosure and amp rack. This will hold 3 woofers and an amplifier in the same piece. We'll begin by cutting 2 pieces of MDF that will be the back and bottom of our piece. The height and depth will depend on the amount of airspace needed by the woofers and the confines of the vehicle. So the piece doesn't have boring square edges, and to make the piece easier to wrap, we'll round off the corners of the piece. An easy way to do this is with a flush trim bit and a pair of MDF circles as guides. Use the circle jig to cut out the desired radius circles for the corners. You may even be able to use scrap pieces from other projects to save time. Most pros will keep a set of various radius rings and discs that can be used quickly for this type of project. Using brad nails, attach the circles to the corners of the enclosure so that the edges of the circle just touch the edge of the MDF in 2 places. Then using a flush trim bit in the router table, trim away the hard corner flush with the MDF circles. Make sure that the flush trim bit is long enough to cut the MDF in one pass, or this technique won't work. After the piece is cut, pry off the MDF circle. Remove or grind down the brad nails if the piece is being reused, and repeat for the other 3 corners. This will give you perfectly round edges. Before we attach these 2 pieces together, we'll want to wrap at the back sides where the wrapping fabric will attach. This allows us to staple the fabric below the surface of the enclosure so there are no lumps in the finished piece. Place a rabbet bit in the router table and adjust the height of the bit to remove approximately 3/16 of an inch from the piece. Then route just the edges that the fabric will attach to. Don't forget the bottom corner of the MDF where the 2 pieces will attach. Now we can attach the 2 pieces together using wood glue and brad nails. Run a line of glue onto mating surfaces and add the brad nails along that line. For extra strength, you can add a glue block along the length of the mating surface edge. This is a highly recommended step that only takes an extra few minutes. While the glue is drying, we can create the woofer mounting surfaces. For this project, we're going to do something different and mount the woofers inverted. We can make the same mounting and trim rings as the first project, but instead we'll simply make a flat disc to mount to. This enclosure uses 3 woofers, so we'll create 3 mounting discs. We'll rabbet the edges of these discs to accommodate the thickness of the resin fabric as well. Be sure to take the length of the rabbet and the mounting diameter of the woofer into account when choosing a diameter for the mounting disc. For the amplifier mounting, we also have the option of either recessing the amp or mounting it above the surface. I'm going to recess mount it for this project. This will be accomplished by creating a small enclosure that will surround the amplifier. We'll use the same thickness of MDF as the enclosure because this amp rack will actually be part of the enclosure and we'll want the extra strength. I'm going to mount this enclosure to the top and back of the piece. This means that the back wall will form one side of the enclosure, so only 3 sides and the bottom will need to be fabricated. Once the dimensions are known, the pieces can be cut on the table saw and assembled using wood glue and brad nails. After a few minutes, the glue will set up enough to allow us to round over the edges of the piece to ensure no hard edges show through after wrapping. As this piece is fully drying, we can create the 2x4 mounts for the woofer mounting discs. For symmetry, the right and left mounts should be mirror images of each other. The middle woofer should be centered on the piece and be at an angle that complements that of the left and right woofers. Cut one 2x4 to the desired height and angle and test the look. Use scraps of wood to make sure your woofer mount is in the proper position. Here I am running a small board along the enclosure edge to ensure the woofer doesn't dip below this dimension. This would cause the piece to have a caved-in look, which is not what I'm going for here. Once you have it the way you want it, mark out the mounting area on the enclosure bottom. To create a mirror image of the mounting point, we'll create 4 lines that intersect with the 4 corners of the original mounting point. Begin by measuring the distance from point 1 and then create a point the same distance in the middle area of the base. Then connect the 2 points with a straight edge. Repeat this for 3 corners. Then measure how far the 4th corner is from the enclosure side and mark a point at this length on the opposite side. Finally, take the 2x4 and line it up so its corners touch all 4 lines and trace its outline. It will only fit one way and this ensures a completely symmetrical piece. We'll be mounting 2 screws to secure the 2x4s to the enclosure so that they won't rotate around a single screw point. First, find the center by marking an X. Then draw a line through this center point to divide the 2x4 section in half. Then draw 2 more X's to find the center of each of these new squares. Repeat this process for the other side. Now cut a mirror image 2x4 piece for the other side on the table saw. Repeat the X process to mark out the 2 screw holes on the flat end of the 2x4. Add a single center screw hole to the angled end of the 2x4 to attach the mounting disc. I want the middle woofer to come out of the piece horizontally, so I'll simply cut its 2x4 square on both ends and add the X's to find the screw hole points. To support the amplifier mounting surface in the vertical plane, we'll use a piece of 2x4 that will attach to the enclosure and amp rack bottom. Secure in place with wood glue and 2 wood screws on each end. The screws in the enclosure can be removed or remain at your option. The glue will provide a sufficient bond after it has dried. Once all of the woofer rings and amp supports are in place, the piece will look something like this. We're now ready to wrap the piece with fabric. We'll again be using the plush felt for strength. As before, cut out a piece of fabric large enough to cover the enclosure with a 2-inch overlap around the edges. Coat the edges of the enclosure and the fabric with spray glue and allow them to tack up. Then drape the cloth over the piece and attach one side so you have a base to work from. Pull the fabric tight and press it in place on the sprayed surface. Warping won't be an issue since our piece is MDF, which is very strong. Once the piece is wrapped and you're satisfied with how tight the fabric is, you can begin stapling the fabric to the MDF. Staple along the ridge of the MDF and fabric where we added the rabbited edge. You can use this ridge as a guide for your staple gun to speed up the process. The staple length is not critical for this piece, but they should be long enough to go through the fabric and seat firmly in the MDF. I prefer to use divergent point staples because they will spread out and hold better in the wood. After the edge of the enclosure is stapled down, repeat the process for the woofer mounting discs and amplifier enclosure. To help pull down the fabric to the amplifier surface, you can use scrap pieces of MDF and staple or even brad nail the MDF to the enclosure. Once all the stapling is complete, go back and run a razor knife along the rabbeted edge. This will cut the fabric perfectly along the seam and will minimize finish work later. The remaining gap between the rabbeted edge and enclosure sides will be smoothed over with body filler in later steps. The piece is ready for resin when it looks like this. We're placing this piece on a row of scrap MDF so any resin drips will not bond with the drop cloth, and we will have better access to the bottom edge. For this larger enclosure, we'll mix up 2 to 3 liters of resin and saturate the fabric as before with a 3-inch brush. Don't be afraid to soak the wrapped edges of the enclosure because the staples will keep it from pulling up. Soak all of the fabric that is exposed except the inner portion of the amplifier enclosure. Only soak up to the vertical edge of this section. Otherwise, the fabric will bond to the inside and it will be additional work to remove it. Set the enclosure in the sun on scrap pieces of MDF. After about 10 minutes, you can flip the enclosure onto the other side so the bottom will dry at the same rate as the top. When the piece no longer gives off heat, it is ready for finishing. First, we'll pry off the MDF scrap that was used to pull the fabric tight to the corners of the amp enclosure. Then trim the fabric until it is flush with the MDF sides using the die grinder and router bit. Use the roll-lock disc and die grinder to further trim the resin edge as needed. Now use the angled die grinder and roll-lock disc to remove the high spots from the enclosure and to remove all of the shine from the exterior. You shouldn't get too many pits with plush felt, but major dips and pits can be filled with body filler. To bridge the gap between the rabbeted edge and the enclosure sides, we'll use regular body filler. Use a thick layer to get adequate coverage. Once the body filler has hardened, the excess filler can be removed with a DA sander and an 80 grit sanding disc. The rear and bottom of the enclosure can either be carpeted or left unfinished, so these surfaces can be left as is. The rest of the enclosure will be painted, so we'll further smooth it with the DA sander and the 80 grit sanding disc. To get a smoother finish on the curves, you can use 80 grit paper to hand sand those areas. Your hand will contour more easily to the curves than the flat DA surface is able to. The final step before paint will be the stiffening of the enclosure interior. In order to get to the inside of the enclosure, we'll need to cut out the woofer hole rings. Remove the center screw from each disc and then use the plunge router to finish cutting out the woofer opening. Remove the disc and then remove the 2x4 by unscrewing the 2 drywall screws from the enclosure. Here you can see the interior of the enclosure. Notice that the resin didn't soak all the way through, which is causing us to lose strength. We'll need to add more resin to this side as we did for the molded enclosure. Mix up 1 to 2 liters of resin and thick tropic powder to form a paste. The mixture should be thick, but not so much that it won't soak into the fabric. Add the hardener and soak the inside of the fabric with a brush. The woofer holes will give you access to the interior of the enclosure. Pay special attention to the junction of the ring and the fabric. Also use some of the paste to fill in the holes left by the drywall screws in the enclosure bottom. While this is drying, we can spray the enclosure with high build primer. An enclosure of this size will need between 1/2 and 1 liter of primer for adequate coverage. Begin by wiping down the enclosure to remove any sanding dust from the surface. Use a disposable rag soaked with surface prep. This will dry almost immediately because it is very volatile. Then mix up the needed amount of high build primer according to the directions on the container and pour it into the spray gun. Put on your fume mask and begin spraying the primer on very thick from a distance of about 8 to 10 inches. Don't worry if the primer begins to run. You'll want a thick layer and any runs can be sanded down. If the primer is put on too thin, you will break through too easily when sanding, or you may not properly fill in all of the sanding scratches and pinholes. To get to the enclosure bottom edge, simply tilt the enclosure with one hand and spray it with the other. Then place it back down and continue covering the enclosure. After the priming is finished, dispose of any excess primer and clean the gun with lacquer thinner and brushes. Let the primer dry several hours until it is hardened and is ready to sand. Then start with an 80 grit paper and work your way up to the final sanding grit. Since this will be painted, we'll use an 80 grit followed by a 220 grit and then a 500 grit 3M sanding disc. Run your hand over the surface and it should feel very smooth with no dips. Otherwise you'll need to add more primer to fill in those areas. Paint is very unforgiving of imperfections, so your surface will need to be nearly flawless. It's a good idea to finish with a hand sanding when you're first starting out. Once the surface is smooth and ready, you can prep it for the paint. Soak another rag with surface prep and wipe down the enclosure. After this is dried, use a tack cloth to get rid of any dust particles that have accumulated or are left behind from the prep wipe. Use the tack cloth immediately before painting or you'll have to use it twice as more dust accumulates. Now pour the paint into the spray gun, put on your fume mask and begin spraying the enclosure. Spray the edges of the enclosure first. This includes the woofer mounting rings. Basically every edge that received a staple on this piece. Here you can see that the enclosure was again propped up, which gives us easier access to the bottom edge. After all of the edges have been covered, begin spraying the rest of the enclosure. Spray evenly by keeping your motion smooth. Start your spraying before and end it after the portion that you're spraying. Start each spray on the same end for a more consistent finish. Don't zigzag back and forth when painting or you'll get erratic results. Use several light coats rather than one heavy coat. Let the paint flash between coats and then proceed with the next. This single stage paint doesn't require an activator, so you will have much more working time than you would with the more expensive catalyzed paints. Once you are satisfied with the paint finished, you can dispose of the excess paint and clean your gun with lacquer thinner and brushes. Once the paint has dried, we are ready to finish the enclosure. I'm going to use a router with a flush trim bit to cut out the opening for the amplifier wiring. A jigsaw or air saw would work as well. We can either leave the bottom and back unfinished or cover them in carpet. I'm choosing to cover them in carpet. To prepare for this, a quick sanding with a DA and an 80 grit disc will do the trick. To cover the bare sides, we'll simply cut a piece of carpet to match the bottom and back of the enclosure. As always, begin spraying both the carpet and the surface that will be carpeted. Try to avoid spraying the glue onto the paint, but don't be overly concerned about it. Spray adhesive won't stick very well to the paint because it is so smooth. Any overspray will be easily wiped off in the final cleaning. After the carpet is tacked in place, take a razor knife and using your cutting hand as a guide, trim the carpeting below the painted edge. As always, use a sharp blade when trimming fabric or carpeting. Make sure the fabric is completely cut before pulling it away, or you'll end up stretching it out of place. Now drill the holes for the woofer mounting screws using a grill bottom as a guide. We do this after the painting so the screw holes don't clog up with paint. Poster putty makes a great temporary adhesive to hold the grill bottom in place while you mark out the holes. For dark paint such as this, use a nail to scratch your mark into the paint. Also mark out and very carefully drill a hole for each woofer speaker wire to enter the enclosure. Use a grommet to make the hole large enough for it to just fit. If you're using a step bit, you'll need to drill from both sides to take into account the enclosure thickness. Now the enclosure can be wired up. Run the speaker wire through the enclosure, out the terminal cup hole, and up through the grommet. Be sure to seal up the area between the speaker wiring and the enclosure to avoid leaks. I'm using regular silicone caulk and pressing it into the open areas of the grommet from the inside. Finally, mount the woofers and amplifier and connect the wiring. There it is, our enclosure amp rack combo piece is finished and ready to hit the streets. Combining colors and textures will really make your projects more appealing. Our final project will be the customization of a stock door panel. It's recommended to use the factory door panel as a base whenever possible, even if major custom work is being done. This ensures a good fit to the door and is much easier to achieve a factory look so the panels look like they belong. We'll also be creating a custom tweeter pod in the sail panel of the door. Let's start with the tweeter pod by taking a look at this sail panel. This is a two-part panel with a press-fit cosmetic cover and a screwed-on base piece. Other sail panels may be in one piece. Whatever kind you are working with, it's important to note the method of attachment because you'll want to ensure your pod doesn't interfere with it. I'm going to leave the base panel as it is and simply modify the cosmetic panel. This piece is perfectly flat, so I'm going to recreate it with a piece of fiberglass. This will allow the working materials to bond more readily than they would with a plastic panel. To create this flat piece, I'm using one layer of 3-ounce chop mat and a small amount of fiberglass resin to soak it completely. You can also use 2 layers of 1.5 or 2-ounce chop mat to get the same effect. I'm creating this layer on a piece of glass so that it will peel up easily. A piece of aluminum foil would work as well if it smoothed out onto a flat surface. While this is curing, let's take a look at the door panel we'll be modifying. This panel was pulled out of a salvage yard and cost less than $20 to purchase. This is a great way to learn and practice without damaging your own door panels or if the vehicle is being leased. This bottom portion is what we'll be modifying. We'll be adding a custom speaker grill to replace the factory speaker grill. The stock 4.5-inch speaker will then be replaced with a 6.5-inch mid-bass speaker. If we look on the back of the door panel, we can see that it is actually 2 pieces. We'll separate the top and bottom portions of the panel. This isn't necessary, but will make the panel easier to work with and won't require the top portion of the door to be protected from overspray. The bottom and top panels are secured with a line of screws on this door panel. Other door panels may be glued or bonded together in other ways, but the modification technique will be the same once the pieces are separated. After we have separated the bottom portion, we can set the top portion aside. To mount our woofer, we'll need to create a mounting ring. We use the same technique we used for the vehicle molded enclosure. We cut the trim ring in a 3/4 inch MDF and the mounting ring from 1/4 inch MDF to minimize mounting depth. As before, the 2 rings were assembled with wood glue and brad nails and rounded over with a router. Now determine the exact location you want to mount your new woofer on the panel. Mark it on the panel using a permanent marker. Then cut it out with an air saw or rotary cutting tool. We're going to bond the MDF ring to the plastic panel, so we need to sand down the plastic in that area to get a better bond. An 80 grit disc in the DA sander will do the trick. A roll-lock disc would be faster, but there's a greater chance of removing too much material. Once the sanding is completed, we can recess our ring into the panel. I'm going to flush mount this ring, but you could also use small blocks of wood to angle your ring. Once the ring is in place, use CA glue and spray accelerator to affix it to the panel. This will provide a sufficient bond until the next step is complete. Apply tape to the backside of the panel to block off any large gaps, such as the remaining grill lines in this panel. This will keep the filler material from pushing through the holes. We're now ready for the bonding material. In order to bond with plastic, such as this door panel, you'll need a special kind of filler material. Ordinary body filler will not hold up because it's not designed for these plastics. The filler I'm using is a rigid parts repair epoxy. This is a 2-part epoxy that is basically a liquid plastic paste. There are several brands of rigid parts repair available, so ask your auto body supplier which they carry. Before using the rigid parts repair, wipe down the surface with rubbing alcohol. This will clean, dry, and prepare the surface for the filler. Rigid parts repair is applied just like body filler using a plastic spreader. Begin by mixing equal amounts of each tube until you have an even consistency. Then fill in the gap between the ring and panel so it flows smoothly and makes an even transition. Spread the filler across the gap and not with it for better results. You'll have a working time of about 10 minutes, which is more than enough for this project. This type of filler isn't as thick as body filler, so you may need to add a second layer in areas that need a lot of buildup. While this is curing, let's go back to our tweeter pod. After the resin is cured, we can pry it off the glass, trace the original panel onto it, and then shape it with an air saw and a roll-lock disc. We'll need to also drill a hole for our tweeter speaker wire to pass through, and a second hole for cleaning out debris from inside the pod. Now we can mount the tweeter to this fiberglass piece using a small wedge of MDF cut to the desired angle, or the angled cup that comes with many tweeters. Rough up the panel in the area where the tweeter cup will meet the wrapping cloth for better adhesion. CA glue is a good choice for bonding the tweeter to this fiberglass panel. We can now wrap the pod with our cloth. I'm using a small piece of polar fleece attached using spray glue. This is a thinner material that is stretchier and not as thick as the plush felt. After wrapping, mix up some fiberglass resin and soak the polar fleece. As always, only resin up to the edge of the fiberglass base or the glue will pull up from the backside. After the piece is completely resined, let it cure. Plastic filler should now be cured enough that we can use the DA sander to further contour the filler. Since we're going to texture the new panel, an 80 grit finish is sufficient, but a few passes with finer grades of paper are recommended. Blend the sanded areas to the original texture to minimize any transition lines using a medium grade paper. After sanding, you may notice some low spots that need extra filler. Mix up another small batch and cover these areas. Let it cure and then sand it down as before. Any small pits in this final surface can be filled in with the glazing putty. Apply it just like body filler. Then sand down after it has hardened. Using the DA, we can also smooth out the surface of the tweeter pod. Remove the high spots and shiny areas using the 80 grit disc. A roll-lock disc would be overkill on a small piece such as this, but it can be used to sand the excess fabric flush with the back of the pod. Now mix up some body filler and apply it to the pod to add strength and to fill in any dips and pits. Smooth it with the plastic spreader around the pod and not up and down. After it is cured, a final sanding with 80 grit is all that is needed to smooth it to an acceptable level for our final steps. Because both pieces are now complete, we can bring them together for their final texture spray and dyeing. The texture spray we're using is the fine rocker panel spray from 3M. It's about $15 a can and is available from auto body supply shops and some auto parts stores. We'll follow that up with a vinyl and plastic dye from Sims that will give us the factory look we're aiming for. Begin by cleaning the surfaces with rubbing alcohol and a disposable rag. You can use the spray cleaner, but rubbing alcohol works just as well to prep the surface. Some surfaces may benefit from the use of canned adhesion promoter, so check with your supplier to see if that's the case. We'll be dyeing the entire bottom panel, so make sure the entire section is completely clean. Then tape off any areas that you do want textured or dyed. Now thoroughly spray the piece in the area of the new panel in quick sweeping motions from a distance of 16 to 18 inches. Apply 2 wet coats and then let it flash about 3 minutes. Follow that with another spraying from the same distance. The finer the texture of your panel, the closer you will want to spray. Spraying farther away will give you a rougher texture. By spraying from farther away, some of the material will actually dry on the way to the surface to give a rougher texture. Concentrate mostly in the area of the new section, but also sweep into the original panel to blend the textures. After spraying is complete, place the piece in the sun for quicker drying. Repeat for the tweeter pod. After the final spraying has dried, you will want to give the pieces a final check to see how well the texture matches. You will sometimes find that a light hand sanding with a 400 to 600 grit sandpaper is needed to give the desired texture. Before the final color coat is applied, the tweeter cup will need to be opened up. I'm choosing to use a rotary cutting tool for this. If you're careful in this step, you can make the cutting bit follow the interior edge of the cup for a flush trim. Follow that up with 80 grit sandpaper that has been rolled up. Twist the paper back and forth so that it follows the interior contours of the cup. Then blow out the dust and debris through the hole previously drilled in the base of the pod. Since the pieces have already been prepped, we can apply the spray dye. These are similar to a can of spray paint, but are a sprayable dye. They're about $10 a can and are available through auto body or auto parts stores. If you can't find the exact color you need, your auto body supplier should be able to mix it up for you. Spray the entire panel to get an even color throughout. Use the same sweeping motions that were used to paint the previous project. Apply multiple light coats rather than one heavy coat to prevent runs in the piece. Our final step is to reattach the pieces to the door panel and the sail panel. Since the door panel was originally screwed together, we can use that method to reattach it. For door panels that were originally bonded together, a line of staples should be used to reattach the panels. To attach the tweeter pod, I'm using 3M emblem tape. This is a super strong double-sided tape that is normally used to hold the exterior trim to the vehicle. It's taking the place of the 3 small plastic pins that were press-fitting the original panel into the base. This is the completed door panel in the vehicle. Compare it with the original stock panel and you'll see the cosmetics match the rest of the vehicle, and most importantly, the panel fits well and doesn't interfere with the door closing. Door panels that are created in this way are quick and relatively easy to do, and still give a custom look without a lot of extra work. The matching tweeter pod will raise the image of the system from that of a door-mounted tweeter, and actually looks like it could be a stock tweeter location. That concludes this video.